Now we're going to look at an example, and we're going to look at each shell. So our first example is n equals 1. This is our first shell. So remember, we have our nucleus right in the middle. And we're going to only look at the first shell, n equals 1. Quantum numbers are somewhat of an abstract idea, so I really want you to get some practice with this. So we're going to go through 4 different shells so you can get a lot of practice and see what these quantum numbers represent and how to find them, even though we've talked a little bit about that already. Okay, so noting that each orbital can hold 2 electrons, fill in the following. Okay, so if n equals 1, our n is obviously going to be 1, right? Okay. Now L, if we remember, L can have any values between 0 and n minus 1. That is one of those that you need to memorize. Okay, so if n equals 1, what are the values L could have? L can only be 0, since n is 1. Okay, now m sub L, you also have to memorize this. M sub L can have any values between negative L to positive L. So what values could M sub L have here? It could only have 0, right? Okay, now how many orientations of the subshell S could I have? Because I only have one value of M sub L, I can only have one orientation. So I can only have one orientation because I only have one value of M sub L. Okay, now the orientations will tell you how many orbitals you have. So if you have one orientation, you're only going to have one orbital. And keeping in mind that each orbital can hold 2 electrons, because I only have one orbital, I'm going to have a total of 2 electrons. So the first energy level, meaning n equals 1, can hold a total of 2 electrons. If you go back in the previous notes, you'll see when we were talking about shells that the first shell can only have 2 electrons, and it's because of this. It's due to these quantum numbers. So here is a picture of the first shell. The first shell consists of only the one S, and notice how it's a sphere. So the S subshell is a sphere, right? What does this 1 represent? This represents your N. Okay, so this is our first shell, n equals 1. Let's look at the next shell, n equals 2. Okay, now here we're going to look at n equals 2. So we have our nucleus. I'm just going to write n. I'll write nucleus so you can see what that means. Okay, we talked about the first shell. That's n equals 1, right? Okay, because I'm kind of running out of room, I'm just going to do a half shell here. We're going to be looking at n equals 2, and we want to know what n equals 2, what that is made up of. We're going to use quantum numbers to figure it out. Okay, so because our example is n equals 2, our n is going to be obviously 2, right? What are the values L could have? Remember, L can have any values between 0 and n minus 1. You have to memorize that. So in this case, it could have any values of 0 or 1. Okay, and then m sub L. What is the equation to figure out m sub L? M sub L could have any values between negative L to positive L. Okay, well, if I look at, let's say, if L equals 0, that means M sub L can only have one value, can only have 0. If I looked at the 1, that 1 can have, or the M sub L is going to be negative 1, 0 to plus 1. Are you good so far? Okay, if you need to pause, rewind, something like that, go right ahead. Okay, so for what I have in blue, I only have one value that M sub L can have. So I can only have one orientation for this subshell. If L equals 0, what is that subshell? It will be an S subshell. And the reason why is because L equals 1. Or sorry, L equals 0, my bad. So again, this is one of those that you have to memorize. Okay, so for the next one, the one that I have in red, how many values of M sub L do I have? I have 3 of them, so I can have 3 orientations for what subshell? For the P subshell, and that's because our L equals 1. Again, that's one of those things you have to memorize. Okay, now if I add up my orientations, really the number of orientations will give me my number of orbitals. So if I add these up, I will get my number of orbitals. So if I have 4 orbitals, and keeping in mind one orbital can only hold 2 electrons, how many electrons can I have? I can have 8 electrons. So that means the second energy level, N equals 2, can hold a total of 8 electrons. Again, if you go back to the previous notes and you look to see where we talked about N, you're going to see that for N equals 2, it can only have 8 electrons, and that is because of these quantum numbers. Okay, so with N equals 2, we can have a few subshells with it. The first subshell is going to be our sphere. Because this is our second energy level, we denote it with a 2. Okay, so because our N is 2, we denote it with a 2, and this subshell is what? S, P, D, or F? It's an S, so we call this the 2s orbital. Okay, so right here we only have one orbital. One orbital can hold 2 electrons. So this sphere can only have 2 electrons in it. Okay, so that took care of the s orbital. Now let's look at the p orbital. Remember, the p orbital can have 3 different orientations. Here we have the first one, we have the PZ, it's called, orientation. The next one we can have is the PX orientation. And the third one is the PY orientation. Okay, now we have one orbital here, another one here, so here's the second orbital. And here we have the third orbital. And keeping in mind, each orbital can hold 2 electrons. So the PZ, this can hold 2 electrons. The PX can hold 2, and the PY can also hold 2 electrons. If you add all of them up, it can hold a total of 6 electrons. Okay. Now, what we can do to simplify this is we can say this is our 2p. 2 represents our N, and then we have our subshell P. Okay, so are we still kind of getting it? Still following along? Hopefully that's the case. Okay, this was our n equals 2. Now let's move on and do the next shell. Our next shell is n equals 3. Okay, so we have our nucleus. We talked about n equals 1. That was the first problem we looked at. Then we looked at the second one, which was n equals 2. And now what we're going to do is look at n equals 3. All right. With n equals 3, n is going to be obviously 3, right? Okay, and what are the values L could have? Remember, this is one of those you have to memorize. L can have any values between 0 and n minus 1. All right, so that means L could be 0. It could mean L would be 1. Or it could mean L could be 2. All right, so now if L equals 0, m sub L could have what values? It could only have the value of 0. If L equals 1, what are those values? -1 to +1. Okay. Again, this is one of those you have to memorize. M sub L can have any values between -L to +L. And the last one we're going to look at, if L equals 2, m sub L could have any values between -2, -1, 0, +1, and +2. Okay, let's look at the one that I did in blue first. How many orientations would this one have? It can only have 1 because I only have one value of m sub L. And because if L equals 0, what is the subshell? It's going to be an S subshell. Now let's look at the one I did in red. How many orientations could I have? I could have 3 orientations because I have 3 m sub L values. And if L, in this case, is 1, what is the subshell? The subshell is going to be P. Okay, and then let's look at the last one, the one in green. How many orientations could this one have? This will have 5 orientations because I have 5 values of m sub L. And here, L is going to be 2. If L equals 2, what is the subshell? D. Okay, now if I add up all my different orientations, that will give me my orbitals. So how many orbitals will I have? 9 orbitals. And how many electrons would I have? 18, because we have to remember one orbital can hold a total of 2 electrons. So if you have 9 orbitals, 9 times 2 will give you 18. So that means the third energy level can hold a total of 18 electrons. Again, if you go back in the notes and you look at the N example, you will see that the third shell, the third energy level, can hold only 18 electrons. Okay, so now that we have this figured out, let's look at the orbitals involved with n equals 3. The first one we have is our s orbital, right? And because this is in the third energy level, we call this the 3s. Okay, so in the first energy level, all we had is the 1s. In the second energy level, we had a 2s and we also had a 2p. In the third energy level now, we have a 3s. And let's figure out what else we have. Okay, we also have the p orbital. In the p orbital, we have 3 orientations of that. We've already talked about that. But this is going to be our 3p. Okay. So far we have 1, 2, 3, 4. We have a total of 4 orbitals. We need the other 5 orbitals. Because I ran out of room, we'll continue that on the next slide. Here we have our d orbitals. The d orbital will have a total of 5 orientations. Okay, so here if I look at all of them, if I group them together, all of these are going to be known as our d orbital. And because our n is 3, we say it's the 3d. All right, so we have one orbital here, right? That's the dyz orbital. We have the second orbital, third orbital, fourth, and fifth. Now remember, each orbital can hold a total of 2 electrons. So the first orbital can hold 2 electrons, second, 2 as well. So all of them can hold 2. If I add up all of those, the d orbital can hold a total of 10 electrons. Here you do not need to memorize the shapes. You need to be able to recognize that this is a d orbital. So you have like the clover leaf shape associated with it, except for the fifth one. It kind of looks like a dumbbell squished in a donut, something like that. You just need to recognize the shape. You don't need to draw them. But you should be able to draw the S and P because they're going to be easier to draw. So the last shell we will look at is n equals 4. So let's fill in our data here. If n equals 4, well then n equals 4, that's going to be fairly simple. What are the values L could have? Remember, this is one of those you have to memorize. L can have any values between 0 and n minus 1. So you could have a 0, a 1, a 2, and a 3. Okay, so if L equals 0, what are the values M sub L could have? We could just have, or it can only have 0. Whoops. The reason why is because M sub L can have any values between negative L to positive L. Again, that's one of those you have to memorize. Okay, let's kind of do the opposite here. Let's maybe fill it in as we go. We only have one value of M sub L, so we can only have one orientation. If L is going to be 0, what is that subshell notation? It's an S. Let's look at when L equals 1. If L equals 1, what are the values M sub L could have? Negative 1 to positive 1. How many orientations is this? 3. And what is a subshell? P. Why is it a P subshell? Because L is 1. Okay, let's look at when L equals 2. What are the values M sub L could have? Negative 2, negative 1, 0, plus 1, and plus 2. How many orientations is this? 5. And what is the subshell? D. Why is it D? Because L is 2. And the last one we will look at is when L equals 3. What are the values m sub L could have? -3 to +3. How many orientations is this? 7, because I have 7 values of m sub L. What is the subshell? F. And the reason why is because L equals 3. So you need to remember the different subshell notations, S, P, D, and F. How many orbitals are there? Okay, you have to add all of them up, all of the different orientations. You will get a total of 16. And if you remember that each orbital can hold only 2 electrons, 16 times 2 will be 32 electrons. So this should say fourth. The fourth energy level can hold a total of 32 electrons. Let's look at the subshells involved with n equals 4. The first one that we can have is our S. Because this is in our fourth shell now, we call this the 4s subshell. Okay, we also have our P subshell, but because we are in the fourth shell, we call this the 4p. Okay, now because I'm running out of room, let's look at the D and F on the next slide. Alright, so the fifth one, or the next orbital we're going to look at has 5 orbitals. We can group them together and we call this the 4d. 4 because that's what our n is equal to. And the last one is our F. So look how crazy shaped the F's are. Now if you look, how many orbitals do you have? So you have a total of 7 orbitals. So that means you have 7 orientations. Okay, now how many electrons are in each orbital? 2. So each one can hold a total of 2 electrons. If you add all of them up, you're going to get a total of 14 electrons in the D shell. Okay, but we can group all of this together so we don't have to write out this stuff, the tiny things that you can't really read. Because we are in the fourth shell, we call it the 4